Okay, so yesterday we covered for Windows session. In Windows session, you see about row number and rank, dense rank, and then lead, uh, lag and all for the previous row, for the next row, and rank, dense rank and all, wherever it is skipping or it is not skipping the numbers for the ranking, right? If you are doing the partition by, then it is giving you ranking for each of the partition, not for the entire data. Like if someone is asking you the question that for the employee data, there are 10 departments. I want top first or top second employee from each department. Then you can do partition by department and you can create the ranking row number. And then you can say where row number equal to 1, where row number equal to 2, like that. Then that will be, you will be easily getting that. For that kind of scenario, you can include window function in your exercise. And my suggestion is to go through that window functions, do at least one time exercise, be hands-on, because that is very critical and that is crucial and required. And 80%, I will not say 100%, but 80% you are going to face in the interview as well. That's the fact. Okay, now moving to next. Here, this is the same data. We were left with the next one, that is sample. And this is nothing else. It is same whatever we already discussed with the RDD and DataFrame. I think this has been duplicated here because we have already discussed about that. But no issue. I will just run this because it's the same. And then we have this one. Let's until this is creating the resources, we can take the next one. Okay, so this drop means, let's say you are having some column, and once you are done, then you wanted to drop the column from the data frame, then you can do using drop. Even without drop also you can do. How? Let's say you have a original data frame df1. Df1 is having column 1, column 2, column 3, column 4, column 4. Okay, then df2 dot select expression. We did yesterday, right? Select expression, and then you can select whatever column you want. Let's say I want to change the order of the column. I can say column 2, column 3. That's it. Then automatically these and these column will get dropped. Get drop means it will be available to this data frame. But when my job is done and I am not applying any action, any further action on top of this, then this is going to be with the lazy evaluation only, right? This is the lazy part. It is not going to do anything. Data will means that this is having just the reference, no data movement and all. So there is no impact. But if you want, you can drop. If you are not, because this is returning the new data frame. If you do not want to return the new data frame, you want to work with the same data frame, then you can go for the dropping instead of the select expression. And this one we use because most of the time we are having some temporary column which we have just created. Let's say you are having a JSON call, JSON data. From that JSON data, you want to extract a column or manipulate the column from temporary columns. So you have some temporary columns, or you want to do some at the temporary level in between, but finally you do not want that once your final output column is done. In that case, we need to drop that, so we use this. Okay, so here we have age column. If you look at this data frame, this is the DF. In this DF, we have name, age, and country. And this one also, let me rename this one as DF1. DF1. And then I will be printing here DF schema, print schema. Here it should print the original schema, and here it should print the schema after deletion. Once you delete the data, delete the column, then you can't revert that. If you want that column again, then you have to recompute that from the previous one. That means this column is available to the previous data frame. This is DF1, and you can again get the column from there. Okay, so here, let me see once on the sampling as well. This was done. False. I believe that you are remembering now true and false, right? For getting the duplicates and making uniqueness. Traction 0.5, that means 50%. That is the original data frame. This is again second data frame. Okay, this is the sample one. Ravi, Ananya, Priya, and Ravi. And what is the original one? Ravi, Ananya, Priya, and Ravi. Only one was eliminated. This Suresh one. This is not there. Okay, so if you see here the original schema, this is 3. Okay, once we drop, then we are having only 2. Each column has been dropped out. So this is for dropping. Most of the time you will be getting the question what all transformation you have used. So you can include these things. Then you are having intersect. For intersect, this is up to this. Okay. So let me. Okay. So you are having one data. This is one data. This is second data, and creating data frame 1, data frame 2. Then intersect data frame 1, data frame 2. I believe that we had did this with RDD. What will be the output here? Okay, tell me what is one here? One and false.
One is it will be show one record only from that dataset.
Okay, so that means limit.
Yes.
And what is false?
False.
Truncate. Truncate data false or true. That means if a string is, let's say I am doing this thing, then if how much string is fitable, that will only print if I am saying true. Means by default it's true only. And if you are saying false, then how long this string doesn't matter, it will print the entire one. Like here, if I am saying false,
Yeah, got it. Remember.
I had said this previously as well.
Yes, yes.
You are getting this right. And
Right.
if I do this true, then it will be giving with few only. So if you have lengthy string, then it doesn't print the entire one if you are not giving this. So say this has been truncated. This we use whenever we are having to, let's say I am processing some JSON, that JSON is means a long string, and I wanted to print that for maybe debugging or doing some analysis. So I need the entire string. So in that case, we do the false. So this is just for truncate. Let me correct this data. Okay. And then this is for intersect. What will be the output for the intersect? If I am doing Ananya, Rohan, Ananya is 2 times here also and here also. Rohan and Priya are unique in both. Column is same. Number of column and name of column is same.
It will give one record only, the common
Correct.
record that is Aranya.
Okay, I think you saw the output.
And no,
Okay. Okay, fine. Then we have next one. Let me comment out this one. Then we have limit. For limit, you have two things. One thing, either you can go with this one, right? Dot show you can see, but dot show means what? This is one of the action which is printing the output, and with limit you can print, but this is not storing anywhere, right? If you want to, let's say your data frame is having some 1,000 records, and finally you want to write 100 record only in the file, output file, then this is not going to help you, because this is just going to print the output in the console. So this limit is for that purpose only. But if you want to limit that actual data before doing or before calling any other action, then you can call this limit, and you can say whatever number you want, you can just apply there. So limit 1. Here, this is the data frame 1. In this data frame 1, as of now, we are having 2 records. If you are saying limit 1, then you will be getting only 1 record. Then final df. Here, just I am adding one of the use case, that once you do the limit, then using with column, we can add a new column also, right? So let's say new column. And then lit, lit value, just literal value, anything. So let's say, mm, no, not applicable. Okay. Then do so like this. If you this here we just most of the time we will move forward with that use case. We apply column, and then we do, even we apply some functions and all. Okay, if you are having UDF, then we go with that. And if you do not have anything, simply you wanted to populate some default value or some literal value, then this is available with the Spark function. You can simply populate any value whatever you want. Then let's run this. So here you can see data has been limited, and this is new column added and with the default value. So here this this is not just displaying the data. This is because we did so. If we are not giving, if I am not doing so, then also count will be 1 only, right? Like here, if you are doing the so, then this is just for console output. But if you do intersect df dot count, then that is going to give you 2, 3, 4, whatever. Here, if I am going to give get count for this data frame, then count will also be 1 only for this limit df, not this data frame 1, because data frame 1 is the original data frame, and that will be having its original data. Here, this we are going to return on top of this data frame. So whatever we are applying the transformation, that will be for this one. Okay, so like that we can go for the limit, then rename. Yesterday we discussed about the rename. With select expression also you can rename, right? Because in select expression you are having SQL like expressions where you can say select the star from, select the column names, change the order, or this column as this, right? Like name as employee name. So there also you can do. Or if you do not want to go with the select expression or SQL-like query, then you can call out Spark Data Frame API where you are having the option with column renamed. Okay. If you go to this signature, how it is, then it is asking for existing string, whatever. Then new string, new whatever you want. Okay. Then you can apply the new name. What you have to give? You have to give new column name. Okay. So let's say we are having final df. Final df is having some, let me give this name, test data. Test data, and here I want to change this test data with rename column name. So you have multiple options. You can do either with the select expression, or you can do with column renamed, or you can do with Spark SQL API as well. We will discuss about that. Okay. If you are going with the Spark SQL API, then simply you can say data frame equal to Spark dot SQL and how you write your SQL query? Simply you can do select ID, name, name age, employee name, from, table, whatever. Okay, like that you can. So which one is better for you, better suited to your requirement, you can go with that. Here if you see uh, renamed column name. Okay, so previously I think I should have printed the data. I have given print schema only. Okay, so let me do renamed df dot so this. Okay, so here if you see here previously our column name is test data. Now that has been renamed with the rename column name, whatever value it's in. So like that you can rename with column renamed, and you have to first parameter is older name, next parameter is new name you want to apply. Then
Case of multiple column rename,
you have to
do
do
we need to
multiple
apply
times.
with multiple with
Multiple.
column rename?
Yes, right. That's why we had discussed yesterday also in the select expression. If you are going for the select expression in the single string, you can do for multiple, right? Like you can say ID age, ID age, employee ID. Then with comma, you can say name age, employee name. So that will be helping you. But here, if you are going for the with column renamed, then for each column name changing, you have to apply this with column multiple times. Okay, like again, you have to say uh, dot with column renamed. This is not coming, but I need to check this one again. Okay, no issue. You have to repeat this step simply. Okay, then let's come for the next one. Any question here for the renaming one?
No.
Okay. Then you have where statement. Again for where statement also, it is same as your column renaming and all. If you want to go with the data frame option, or you want to go for the select expression or Spark SQL. Here you are having where clause. Either you want to apply the where clause with the traditional SQL type, or you are taking this one. So df dot where cells is greater than 40. So whatever condition you want, you can simply put on the data frame with this one without any writing. Select the star from table name, give all the conditions where this condition is greater than, less than, equal to, whatever. Okay, so you can avoid that and simply you can opt this one. If you say let me delete this will fail, and let me comment out this, then comment out this filter df. So where cells equal to greater than 40. Why this failed? This is filtered DF. This is saying a column or function parameter where cells can't be resolved. Okay,
Primary column not there, I think.
column name is not there. Okay, this is DF1. In DF1 we have cells. So I need to do DF1. Here if you see, this is filtering the data 500, 600 and all got eliminated which was less than 400. Okay, then this one is something you should know. Okay, this drop. Okay, so here if you see drop rows with null values from a data frame. Drop NA, you are having the parameter. Always these are optional, not required that you are giving. Simply you can say drop NA also with parenthesis. That is going to work. Like you can say df dot NA. Sorry, df dot drop NA. Drop NA. This is also going to work for you. So let me have one data frame particularly for this use case. Let me comment out this and I will copy this data frame down. And let me, I will create within here with some null and all. So here, let's create it. Can say subset product. I think I have taken based upon this data frame, right? So I need to change the column name. Okay. So let's say I will change here with age based upon the data frame. And I will make it null. This one also null. This one also I'm going to make null. Okay. Now we'll run this. This is going to fail.
Null, I think N will be capital.
Is it? No, this is in black color only. Its color should be changed, right?
It should be none.
None. Yeah, in Python, anyway, by default, this is none only. Yeah, you are right. But okay, let me keep it with null only. Let me see whether this is keeping this means treating as null or what. Because this should get treated as a string, not null. Let's see. So this is null. I made so many null or what? I did this one only. Okay, this is taking a reference for this one. Let me comment it out. Then run it. So if you see here, data frame, string, age, country, I think I have no. So So if I am giving here df dot so, there it will be printing the actual, and then dot drop in, I will be printing here df dot so again, and here also subset age. You can see the differences here. It is saying about subset none, subset age. Then again I will say df dot so, and here also df dot so. But for now I will be printing one only, otherwise you will get confused. Two we are going to print, one with the original one, and let me comment this line as well. We'll do with simple drop in. If you see the output, this is still coming with output data frame column name only. Why? Why this is not printing that? df dot so, df so, why this is printing like this? Image begin, but we are not looking for this. Okay. Let me do this separately. Okay. So this one is the data frame. Now this is our original data frame. Then we are saying df, let me create one thing. df drop drop any means we are by default it is going to take any. Okay. Then df dot drop any. Let me print this one. We'll go one by one. Let me comment. df dot so, df drop any dot so. Then this is for any. Any means what? This deleted all the none, but this not this null. You know the reason, right? This is getting treated as a string, not null. That's why this is not considering it as null value. Otherwise, if that was the actual null, then it could have also deleted. Let me make that. This is the default property of Python. This not for the null value. Then if you see here, that also got dropped. Okay. Any means what? It is checking for regardless of the column. Anywhere, if there is any null, then that is going to drop. This one you can keep in mind. This is not checking for which column name, for any of the column. If any null value got recognized, then the entire row is dropped out. This is the difference. Next, we can have all. All value means drop rows where all values are missing or it is null. So let me do the same. Let me copy paste it. So here drop any. You are having the parameter option also. You can say how. How means all. So all means it will be dropping the rows where all values are missing. Okay. Otherwise, no. Let me print this and see the output differential between previous one to this one. What do you see? This is not replacing. Okay. This was replaced because we had given drop NA and we did not give any parameter. We did not give any parameter. That means by default, this is taking NA, how equal to NA. Okay. Here we defined how equal to all. All means all columns means it should be there should be complete null. So now let me create one of the example. So here this is nothing gets eliminated. All the null values are here. Let me change that. Let's make for the example here also none and keep this one also none. Now that was deleted, right? After Suresh, this did not printed. That means it is having all null value. Then that was eliminated. If there was a single null, then it was existing here in the output. So if it will be dropping the rows where all the values are missing, not for the single column or multiple column, but not for all the column. Next, you can check for threshold. We have threshold options also. While you were providing these kind of like here for this example, you can see df.na, then you are saying any means this one by default it was any only. Subset you are saying none. You are having threshold value. So these parameters are completely optional. Either you can keep all three or you keep any two or keep single one or nothing. That's completely up to you. So I can say let me do this drop df drop with the threshold equal to df dot drop na and then let's say thresh equal to 2. So what this will do, this will be dropping the rows where less than 2 non-null values are present. Okay, this will be working based upon the threshold value. You can check it out. So comment this and do df underscore thresh. Okay, drop threshold dot show. Let's run this. Now here you can see a output is still same. There is no differences between this and this. So need to keep some changes in the data. Let's make this one also none. Now that got deleted, right? Deleted from the output. That's not existing here. So this is going to work with the threshold value. If you think that okay, any of the row which is having null values for more than these many columns, then eliminate that. Then you can give a threshold value and this is going to work. So but this threshold you can give along with the condition, other condition like how any, then subset none and all. Then you can have subset one. Subset one is for, let me run for that also. Then you can combine all. Df drop subset equal to df dot drop na and then subset equal to what is the column name? We have name and country. Let's take country. Okay, then print this subset should be subset, not set dot so. Okay, so this will be dropping the rows based upon the specific columns only, not for all the columns. If you are saying how or all or a means in how you are giving all or any, then that is doing accordingly. But if you want to do based upon the specific column name, that let's say you are having 20 plus columns, you are not worrying about any other column except these two. You are thinking that okay, if name is having a null, then drop. If country is having null, then drop. Don't care for any other column, either that is having null or not null, don't check that. Okay, so if you are doing like that, so let's have a look on the data. This is the country one. Country is having, let's make it not none as of now. I will make this again, let's say UK. And this one also I am making USA. Now run this. So as of now, country is not having any null. None name is having two null. So let's run this. See the output. So this is taking this name was having two, that's why this got deleted. Okay, and it has taken UK for one. UK because this was Suresh. This was also not null, this was also not null, and we are giving condition only for two, name and country. We are not caring for age. This column, either this is having null or not null. This should also not be the part of output, but this is because we are not considering any or all. We are just giving the condition for the columns. Like here, we are having the column condition. Here, let me take some name. Let's say Ram. Here I can give Shyam. Okay. Now nothing null in the name also, in the country also, but null exists in the age column. If we do, then nothing is going to eliminate because there is no null. Whatever we are checking in our condition, that is not fitting. So we are going to get the entire output, right? Like this. Then let's make this complete. This one. Let's say df drop check all equal to df dot drop any. You are saying how equal to any. Then you are giving subset also. Subset you are saying none, means you are not checking any of the column. You are saying trace also none. Let's run this. And again, you can remove both, not mandatory that you are going to give that. This is completely optional. So if you see here the output, for the final output, this is giving the complete one, complete output. Why complete output? Because you are saying how any subset none. Let me give here age. Okay. If I say age, then it got deleted two records because for two age was null. So now it is checking for the null value. Now if I eliminate this none and take this as all. Now run this. Okay, you can see there is difference, output difference as you can see. And again, you can do for two only. Let's say we are doing a subset, and let's remove this completely. I do not want to based upon the column. Here I can say one. Now run this. So Now this is going to take based upon the okay thresh we gave for 1 and let's say any. Now let me run this. I think I'm doing something wrong. Yes. We make it. But we do not have anything where 2 are none. We have single null value as of now for the age only. So it will be remaining. It will be same. Yes, this is same only. Okay. Then we can just pick one of the example here. And okay. Then we can move to next one. Drop in. Let me delete it. Again, drop in. This is also not required. This is the another data set. And this is data frame, creating the data frame, then drop null. Let's do this. Let me comment out the previous one, whatever we did. Okay, so we have data is having some null values, and you are having name, age, and city column. Drop null. First, this is going to print the original one only, okay? Because we are not doing anything. So you are going to get original data frame, name, age, and city. Next, do the, this is also related to same example only. Drop with threshold. Okay, just a check. We are applying NA. What you are expecting in the output? If you see the output, this is the data. What should be the output data?
We'll check for null value and for any column. Okay, it will drop the rows wherever it got the null value.
Only Ananya will be there.
Okay, only NA. Let me check. Yes, only null, because this is checking for NA. Anywhere if there is any null, that is going to be eliminated. Then you have another one, fill NA. What is this? This is for filling some value. Let's see the output here. Then you can understand it. What this is doing. Okay.
Name will be replaced NA with unknown and age will be 0 instead of none.
So name got replaced with unknown and this one got 0. So this is simply to replace the null value, right? So if you in the like if let's say you are working for the SQL, then in SQL you are having multiple options to replace the value, handling the null values, right? Either you want to replace or you want to populate some default value and all, or maybe you want to do some other operations. Then you can do some concat and all, or populating some default values and all. Here in the Python, you are having fill NA, where this function is mostly used to fill the missing or null values in the data frame with a specific value or whatever values you want to default. Here we can say, let's say we are having this data frame dot fill NA, and you are saying name. If wherever this is null, then populate unknown. For age, wherever this is null, populate 0. Okay, like that you can. And okay, so fill null. So here what we are doing for multiple columns. If you have to do for the single column, you can do like this also. Let's say df for single column. You can opt any of the option. Then df dot fill na, and then let's say default. And I'm saying subset, just like above one we were doing, subset equal to country, whatever country we have. So name is city. We had one column city, right? Let me take city, and then this will be handling for the city column. Let me do for print single column dot so. So let's do this. What is the error? Data frame object has, okay, spelling mistake. Fill in. If you see here, this is populating default value for the city. But again, this is not the only option. You can see here also, if you are giving, let's say city and unknown, you are giving for single column only. Then what is the output? Error. Closing parenthesis doesn't match. Okay, this one. So here if you see, this is also good, right? So there also you can have the single column, and here also if you are giving, let's say name, and I am just so this is also working, right? If you see, I did not print or what, city and name. Let me do print all. Print all. This is the output. So this is taking default for name also and default for city also. What differences you understood from both of the example for this one and this one? What did you what you identified? Anyone? No, you do not get any differences between both.
With fill in curly brackets, we can give different values, but here we can have same value to
Right.
replace.
Right. So here also you can give multiple columns. Here also you can give single column, but here you have flexibility that for each of the column you can have different value to be populated. Here, whatever you are giving, this value will be populated for each column, whatever you are defining in the subset bracket. Okay, so this is only the differences. Otherwise, you can go with this one or you can go with this one. So if you have single value to populate for each of the column, you can go for this. If you have the specific requirement that for this column, this should be the value, for this column, this should be the value, then go for the default one. That is going to help. Okay, so these are some basics transformations we have in PySpark. Okay, Then let's go for the next one. Just give me 1 minute. Okay. Then any question here for these transformations and all? Because I have tried to cover almost. If anything is missed, that should be covered. Please let me know. Okay. Then next we can let me comment out all the things except this first data frame. Both the data frame. Let's be it. Then we have one data frame, and the second one was data frame 1. Now we have Spark SQL. Okay, let me cover that as well very quickly. Spark SQL. So for Spark SQL, if we talk about the overview, then this is also part of Spark, right? So this is a module in Apache Spark that allow querying structured and semi-structured data using SQL. If you are good with SQL, if you are a good SQL developer and you are not good with the programming, then you are good to work with Spark. Using SQL, you can do lots of things. It supports a wide variety of data sources such as Hive tables, JSON, Parquet, Auro, JDBC, and many more. And it provides the ability to use standard SQL queries. If you are good with SQL query, then I can say that almost 99% of the queries and functions you can adopt. I am remaining for 1% because there are some, of course, that is the, let's say you are working with Oracle, Teradata or MySQL. There are something specific can be there for that platform. You can exclude that. Even that may get supported by Spark also. You can check once, but you can keep either 1% or 0.5% something for that condition if that is something specific for the platform. Otherwise, that is going to support. So this is going to support your standard SQL queries, and you can go for integration of SQL queries with the data frame operation. Whatever you here you above you seen, right? Like you want to apply fair, or you want to give some other conditions, or changing the name, or adding the name, changing the order of the column. You can straightforward you can do with the data frame API, either with column or select expression, or maybe some different option. Here with the Spark SQL also you can do the same. You can query the data stored in the distributed storage. Let's say you are working with either HDFS in Hadoop, or in AWS you are having S3, in Azure you are having ADLS or blobs. In if you are working with GCP, then you are having that Google storage. So that all the things you can get supported here with this Spark SQL, and you can query the data from those distributed storage platform and optimize query execution using the Catalyst optimizer. That is the default property or default nature of the Spark SQL. Okay, that you are going to get. That's a kind of optimization provided by Spark. You can remember this word Catalyst optimizer because in interview also this can come as a question, what is Catalyst Optimizer, or what kind of optimizations we get while we are using the Spark SQL. So you can go with this. When we use this Spark SQL, then what we have to do very first is Spark session, because you are going to work with DataFrame, Dataset, or RDD only. So either you need a Spark context for in the case of RDD, or if you're working with the DataFrame APIs, then you can go for a Spark session. Then register a data frame as a temporary or global table. That is the main thing. Then run the SQL query using Spark SQL. So here, if you see, let's say you are having a data frame. Data frame, if you want to do, let's say we are having already one data frame, right? So let's do data frame dot show. Then you are good to print the data, right? This is going to print data for you. Here you are good to save, but let me have a print here. So we will make sure that we are going to get all the output for Spark SQL only. Print Spark SQL. Now this one. Again, if you want to use the Spark SQL on top of that, let me take this is df SQL equal to df Spark dot SQL and select a star from df. df, we are just trying to treat it as a table. Now let me do the show df dot show. Let's run this. This failed. This is saying analysis exception, table or view not found. The table or view df cannot be found. Why this is? Because we have data frame, right? And we are good to print the data frame here. But why it did not took here? Any idea? Okay, so this is SQL API. This is looking for a view or a table, but this is not looking for a data frame. That's why this is not good to work directly. For that, you have to register your data as a temporary view or temporary table. Then only it can help you. Okay, for that case, you have to register this. And what you can do, let's say I am registering that as a temporary view. So df dot create or replace temp view. If you see here, create or replace temp view. Let's say test. And now let me do test. Now let me run this. I have to do this name. Okay, now this did not get failed, right? Why this did not get failed? Because now this is good to query from the test. Test is a temporary view as of now. I have registered this data frame as temporary view, and then I am using this. So we can do like this, and let me print this with, I just wanted to check something. I will go with the code here. We'll create a new Spark SQL, and I will copy complete from here. Let me delete the entire in between things. So if I check here, Okay, here I am getting. Here if you see you are having create or replace temp view, then you have create temp view, temporary view. Here you have create a global temp view and create or replace a global temp view. Okay. So if I say about create or replace temp view and create temp view and create a global temp view and create or replace global temp view. Then what is differences between them? And once we are done with the use of these temporary views in Spark SQL, then finally we can delete these instances. Okay. So in that case, we are good to set the memory occupation and all. Okay. So let's go for one by one. So we can see 4 instances. If I talk about the, let's say start with the create temporary view. So create temporary view creates a temporary view that allow querying a data frame using SQL, and this will fail with an error if the view already exists. Because we are not saying to replace temp view, right? We are saying to create temp view, just like our Spark, just like our SQL query. We say create table name, and we give a, sometimes we can give a condition create table if exist, if not exist. Right. So if you are giving the conditions of if exist, if does not exist, then it will check and it will kind of replacement. But if you are not checking anything, then this will simply try to create, and if that is already existed, then this will fail. So this will fail if the view is already exist, and this will only available within the current Spark session. Anyways, if we talk about this temporary temp view or temp table, whatever we are creating, that is for Spark session oriented. Once your session is closed, then it is gone. Again, you have to register. Means that will not be available. It will be the missing value. And the view is automatically dropped when the session is going to be end. If we talk about this create temporary view, then create or replace temp view, which we already seen. So this create a temporary view and it will replace if that is already existed. So like that, like this create temp view, this will fail, but this will not fail. If that is existed, then it will replace. If that is not existed, then it will create. So that's the thing. Then it replaces the existing temporary view, because if it is checking for the replacement, if that is available, then that will be replaced. And this is again only available within the current Spark session. It is same, and this view is also automatically dropped when the Spark session ends, just like create temporary view. So there is no much difference. Only difference was this will fail if that is existed, and this will replace if that is existed. That's it. Then we have another one, create a global temp view. Okay, this one. So create a global temp view. This creates a global temporary view. So you can understand now local temporary view, global temporary view. So this creates a global temporary view that allow querying a data frame using the SQL. And this will again fail if the view is already exist, because we are not talking about replacement, right? And this will be available across all the sessions within the same Spark application. If you have multiple Spark sessions, then this will be available for all, because you have given the keyword global. That means this is globally application for that entire Spark application. Okay, whatever Spark application you are running till end to end. For that, if it is having the single session or multiple sessions, this is going to be available across all the sessions. And uh, this view will be also for the dropping wedge, same behavior. It will be dropped when the Spark application ends the task. Once the Spark application is done, then this will also be done. Okay. Then you have next one. What was the next? Okay, this was. So create or replace global temp view. So this is again for creating a global temporary view, and that will get replaced if that is already existed. Just like the above one, this will not fail. And This will be again available across all sessions with the same application, and this will be also getting deleted once this Spark application is done. Okay. And if you want to drop the temporary view, let's say you were done with your task, you know that at the end of the application, this will be automatically dropped because this is session oriented and application oriented. Okay. So if you are talking about the replace view, temp view and replace temp view, this is session oriented. If you are talking about the global, then that is, this will be available until the application is getting end, that is running. Okay. But if you want to do, let's say you were done with the task, whatever you wanted to. And after that, again, you are going to do some 10-20 transformation, but this will not come in the picture. This is not needed. Next, then you can drop it. For dropping, you can say spark dot catalog, then drop temp view or global temp view, whatever you have created. So let's say I have created temp view. Then you can say what is the temp view name. So my temp view name is test. So this is going to drop that y2 times bracket. Okay. Similarly, if I have created the global temp view, I can do the same. I can say drop global temp view like that. Okay. And then you can query all kind of SQL queries here. Fine. So here if you see, let's say I am saying select star from. You can have multiple things like select name, select country, edge, employee location, and then I have to take data frame. Data frame is having name, age, and country. Employee location, name, age, employee name, from, view, where age is greater than 30. Okay. Anyone is having greater than 30? Yes, only one person is having 35. One person is having 30. So let me make it greater than equal to 30. Okay, so you can simply call whatever you want to. Let me run this. Why this is failing? CRA, where I have given this. DF dot line number 41. Okay, this cell. So when we drop these things, then this is going to make sure that resources are released, and this will be ensuring a long-term memory occupation. Otherwise, this will be dropped when our Spark session or our Spark application is ended. But that will be when Spark is going to do that. But in between, if you feel that this is no longer required, you can drop on your own. Okay. So what is the issue here? Anyways, this has filtered out. This is failing because this global temporary view is not available. If I see the error, this is saying unable to database default. Okay. And exit exception. Okay. Global temporary view, because I have not created. So if I have not created, how it will delete, right? I have only temporary view as of now, this one. So this is going to print this Ananya answers only. They have age either equal to or greater than 30. And another thing is EMP location, EMP name. That means if you want to change the order of the column, then here and there you can do. If you want to do renaming or dropping means I did not selected the age. That means it's not there. Okay. So almost all the things, whatever you are doing with the DataFrame API, you can go with the SQL one. Fine. So if you are good with SQL, you can apply the query like you write in the SQL, and simply using by calling this Spark.sql, you can write the any either simple query or complex query. This is going to support. Only thing is you have to register your data frame as a global view or temporary view, and then you can call that. Finally, if you want, you can drop. Otherwise, finally it will be getting dropped once the Spark job is done. Now, when we talk about Spark SQL, then this can be the question that how you are going to use and why you are going to use, right? So why we should use SQL and Spark? Because we are having data frame APIs also, we are having another options also. You are having a Spark streaming, Spark core, Spark some other options, machine learning, so and all multiple APIs are there. Then this Spark SQL is having its own advantages. Using Spark SQL, whenever you are using this provides a several advantage, particularly when we are working with the structured data, mostly structured data, because this is having naming structure, columnar, right? Data is getting divided into columnar format with the column name and records. And whenever we are working with the structured data and we want to leverage the power of SQL based querying, if we are good with the SQL part, then we can go. And major things to use this, one thing is familiar with the SQL and its simplicity. If you are familiar with the SQL syntax, then this is really good. And this is going to provide a declarative approach as well. Like SQL allow us to describe what we want to do with the data rather than how to do, right? And making it easier to write the writing and understanding the complex data transformation logic within just a single line or multi-line queries like your SQL one. Another main thing is catalyst optimizer. As I said, you should remember this word. This is going to be part of your interview. Catalyst optimizer. Okay. So a catalyst optimizer in Spark SQL, this uses an optimization engine that is called catalyst optimizer, which automatically optimize the SQL queries to improve their performance. Whenever you are writing a Spark in Spark SQL, whenever you are writing a Spark SQL query, and let's assume that this is very much complex and this is taking lots of time internally, then Catalyst Optimizer is enabled with the Spark SQL, and that is going to help you to optimize the query internally without letting you know. This is not going to ask you that do this. If you are doing, that's good. Otherwise, this is also going to take its own responsibility, and that will be helping out. So this is Spark SQL uses this optimization engine, Catalyst Optimizer, which will automatically optimize SQL queries to improve the performance of the SQL query we have written. What it does internally, it will be doing the predicate push down. Let me note that keyword. Predicate push down. And okay, so when I talk about predicate push down, then filters are pushed down to the data source level, Like either you are using the database or you are using any other distribution file system, let's say S3, ADLS or HDFS and all, reducing the amount of data loaded into the memory. Okay, then you are having join optimization. Next one. Join optimization. For join optimization, the optimizer decides the best way to join the tables, like choosing a broadcast join or a smallest data set, how it is going to do. So internally, this will get defined. Then aggregation optimization, because here also you can say, right, from test A, let's say join employee table, let's say this is B, and let's say you are having one more here, let's say df1. df1 you are registering as employee table, and here you are saying a dot country and a dot name, and a dot name as employee name, test A, employee table B, you can say, and then you can say on which condition you want to join. Let's say A dot ID equal to B dot ID. You are having some column name. Just assume that you are having a column name. So here also you can have some joinings and all, right? So there can be a condition where table is one table is a smaller table, one table is a bigger table, or both can be small, both can be big. Anything can be there. You can have more than one tables as well. So in that case, this Spark SQL Catalyst Optimizer is going to take care of that internally. This will be helping you for join optimization. This optimizer will be deciding the best way to joining the tables we have given, whatever it can choose in internally, like broadcast or smalling data set, in which uh, condition that will be more better. Then aggregation for the optimization. So aggregation optimization, if you are having any operations in this query, like let's say you are applying some aggregations and all. So in that case, it is going to help you for the aggregation optimization. So aggregation operations are optimized by combining them with filtering and reducing unnecessary data shuffling. Okay. Then cost-based optimizer. So for join optimization, you have, let's say, one aggregation optimization. And then you have cost-based optimizer. Cost-based optimizer. This is CBO. In shortcut, we say it. Okay. So Spark can use statistical data like data size or distribution to choose the most efficient plan for the execution. And all these are happening internally only. You are not going to do that by any action. Okay. So about this question can be there about catalyst optimizer, or maybe they may ask what is the difference, means why we are using Spark SQL, or what is the benefit of using that. If benefit is coming in the picture, then of course you can talk about this catalyst optimizer, and then you can talk about its properties and all. Another thing is for the Spark SQL compatibility with the structured data sources. We know already that SQL means what? We are going to work with the structured data, which is having row column structure. We are having the columns, we are having the data types and all. In SQL, you are having the data type. In Spark, we are not defining the data type. Based upon the data, this is going to pick the data type. And if we want, we can do the we can create the schema with the particular data type, or time to time we can do the typecast. So it supports for external database like Spark SQL can connect with the relational database as well. Let's say you are having the data in the Teradata or Oracle, Postgres, MySQL, SQL services, SQL servers and all, and you want to load the data from there, then you want to do some operations. You can do that. You can connect with any of the database and you can query them via JDBC. And it also integrates seamlessly with data lakes, like you are having Delta Lake or you are having Parquet or maybe other, and the data warehouses as well. Like in Hadoop, you are having the Hive, you have BigQuery, you have Snowflake, and many more. Then Spark SQL provides a unified interface as well. We say it unified API to query structured data, whether it resides in a file format or a NoSQL store or NoSQL store in the sense Cassandra or MongoDB, you can say. File format, you can say like CSV, XML, Parquet, ORC, JSON and all. But XML and JSON is not the file format. That is a type of file. If we talk about file format, then that can be the CSV, Parquet, ORC, RC, and all, or a relational database. Then simply we can do the integration with the database using the JDBC with the DataFrames, datasets from different sources to read the files and all. And then we can apply the Spark SQL on top of the data. So Spark SQL is tightly integrated with the data frames and data sets. When we execute SQL queries on data frame, the result is a data frame which allow us to seamlessly switch between SQL and data frame based operations within the same program. So within the same program, you can use Spark SQL also, you can use Spark DataFrame API also. Not that if you are using Spark SQL, then you cannot use Spark DataFrame API. Of course you can. Here you have used this SQL one. Now you can say df.fair. You can do again whatever you want. You can do the filter. So you can go for the Spark SQL, you can go for the Spark DataFrame API, DataFrame dataset altogether. Then question can be how it is optimized. We already discussed about Catalyst optimizer, right? So Spark SQL uses several techniques to and components to optimize the query execution internally. And first thing is Catalyst optimizer that we already discussed, where internally it creates a logical plan, then logical optimization, then physical plan, then cost-based optimization. If we talk about logical plan, then simply like Spark architecture, you can remind here. When a query is submitted, Catalyst will be generating the logical plan that describe the operations Spark is going to perform. Like whatever you are talking to take the, you are asking to select the column names, then you are going to do the join, you are going to do the filter and all. Then logical optimization. Catalyst is going to apply various optimizations to the logical plan, like constant folding, uh, a constant folding in the sense you can say like evaluating expressions that don't depend upon the data, and a filter push down in the sense moving filters closer to the data source. Like whenever you are reading the data, let's say you are going to read 1 TB of data, there itself while reading itself, instead of reading the 1 TB of data, why not to filter at the same time? So whatever is required for you, pull that much data only. What is the benefit of pulling all the data which is not really required? So that you can go for filter push down to move filters closer to the data sources. Then physical plans. Once the logical plan is optimized, these are all things are going to be happen internally only. When this is going to, for going with the logical plan, then physical plan. Once the logical plan is optimized, then Catalyst will be generating one or more physical plans which describing how the query will be executed, means what has to do, how has to do. It is going to take care. Then we talked about cost-based optimization. So for cost-based, this is for Catalyst, this statistics kind of detail, such as the size of the data set and the column distribution to choose the most efficient physical plan and all. So when we run our SQL query to filter the data, Catalyst might push the filter operation to the data sources rather than loading the full data set and filtering in the memory. So if you are loading the entire data set, 1 TB of data, then you are doing the filtration in memory, that may cost in the sense it may take some time. It is going to occupy lots of memory, processing time, loading time, everything. So if you can go for this filter push down, then this is going to help you to load unnecessary data. Okay, and then you are having tungsten execution engine. One more keyword is there that also usually comes in the interview. Tungsten execution engine. Okay, so if we talk about tungsten execution engine, then this is also having some stages where it creates the physical execution optimization, then off-heap memory management and the code generation. Okay, that is what it does internally. Where the tungsten execution engine is designed to provide low-level optimization for memory and CPU efficiency. And it optimizes both the physical plan execution and the memory management for the operations like sorting the data, shuffling the data. And again, remember that you are not going to write anything for Catalyst or Tungsten. This is already defined with the system and this is going to take care internally for you. Only you have to know what it is, how these optimizers are going to help, but you are not going to do any code. Then off-heap memory management is associated with it, where Tungsten uses off-heap memory for the data storage, which avoids the overhead of JVM garbage collection. Okay, and this will be resulting in improved memory management and performance. Of course, if it is reducing the JVM garbage, then of course this is going to help you for the memory management and performance will be more better. Then code generation. For many operations, Tungsten can generate custom bytecode for each of the operation, and that is going to reduce the runtime overhead. Like that, it works internally. So if it works internally, if I have to describe in short, then I can write for the physical execution optimization. Then off-heap memory management. Off-heap memory management and then code generation. Code generation. Okay. Then in the Spark SQL, you are having the data locality. Data locality, it means Spark SQL optimized data locality to minimize the network overhead. It is having partition pruning. Partition pruning in the sense Spark SQL will avoid scanning partitions that are not relevant to the query. So if you are giving the filter column, let's say here I am saying filter by. I am giving some conditions, or maybe you are giving some partition column, then that will be doing scanning for that one only, means that is simply going to the filter. So when filtering on a partition column, then that only will come in the scanning part. So this will avoid scanning the partitions that are not relevant to your query. Then partitioning and shuffling, where it will take care for efficient partitioning and shuffling reduction and join optimization for the broadcast one, shuffle joins and indexing if available. So for indexing, I can say Spark can use indexes for certain operations if you want. And in case of external database or optimized data sets, but this really doesn't support like a proper database you are having. Okay. So there, because in Spark, if you are going for the indexing, you have to create in the Spark way how Spark is supporting, not like how uh, a relational database. Because in relational database, we have option to make the relation also, like we create a star schema and what means a different design we provide for the tables and all. So like that you can do here. There is it is having its own advantage and disadvantage, but yeah, you can relate if that is available, then you can go for that as well. And then if you for the optimization, you can go for using partitioning, broadcasting, caching, how you can cache the data, that all you can take the consider. So this is about the Spark SQL. This is again one of the API and one of the best thing in the Spark. I will say that if you are good with SQL, then you have not to worry about that. This is simple 2-3 lines of code. Simply whatever data frame you have, register that. Once your registration is done, then using spark.sql, once your Spark session is created, write the query whatever you want, and that's it. You are done. Simply, finally, if let's say this is your final data frame, then df.sql and you can dot write. Okay. So dot write, sorry, I have given wrong. df sql dot Right. Now you can write it, you can save the file. You means that is the final output and you can do whatever you want the next option. If this is optional, if you are thinking that this is not needed and your application is going to run for another transformation, then you can drop. And if you're not dropping, then anyway this is going to drop at the end. But the good practice, you can drop out if your application is a big application, this is going to run for the longer time. And if you think that this is not needed and unnecessarily this is keep on moving here and there, then let's delete, let's drop. You can take it as a best practice. So this is what about Spark SQL. Anyone has any question, any doubt, anything?
No.
Okay, fine. So I will only say that go with each of the option. If we discussed about 50 and 100 transformation, if I include that narrow and wide one, we discussed almost 100 of the transformation. I am not saying that you have to remember all 100, but if you are targeting for 20 also, be sure that you are good with that 20. If someone is asking, okay, what transformations you have used in your project, if you should be naming out all those 20 very frequently with confidence, and if questions are arising from there, you should be good to answer, you should be good to explain, then trust me, you will be good with the position in the interview. Okay, output will also be positive. So the concept is, if we are discussing with lots of points, not always not necessary that you capture all the things, but whatever you are capturing, capture well. And again, based upon depends upon experience also. If your experience is less, then less knowledge is also fine, you also know, right? And if you are having more experience, let's say someone is coming with 10 plus years of experience, that means when you are going for the interview, what is the expectation? Expectation is not only an individual contributor or a developer. Expectation is you have to be an individual contributor also, but you have to lead the team also. You have to review the code also. You have to guide them also, right? If freshers, interns, juniors are there, so your knowledge should be up to that level. So make sure that you are following that. Based upon the experience, you have to prepare yourself. Then that will be really easy. And trust me, this is not hard at all. That's what I can say, because see, yesterday only I got a call from Vamsi. In the initial call also for this batch he had joined. My last batch got over by 20 December. It was the last day for that batch. 20 December means today is 28th, right? It's 28th day. And in between, he went through 3, 4 interviews. He got rejections in first round also, second round also. But that happens. That's expected. We can't say that we will be getting. He's from fresher. He joined TCS. So in TCS, you can understand, right? Always you will not be having the project. Sometimes bench, sometimes project. And he is stuck with the project of the ATL, where he is hardly using 2 to 3 tech stack. That's it. But he wanted to move out. But I will appreciate his hard work. He really uh, contributed, and means he dedicatedly he contributed over the projects also. Whatever project I had said, he did that, and he was following up with the exercises. And even he had lots of questions as well if he is missing something in the exercise and all. And yesterday he had called that he got the offer, and he has, you can assume in TCS less growth, less salary and all. He has received almost 100+%. So that's really a good moment. Even I suggested him that don't stop, keep on searching again. And maybe next time again you can gain 100% on top of the current one, because that's possible. That's not impossible. We can get it. So I can say only one thing, the dedication. Every day, at least keep 30 minutes for this. Okay, for the exercise, if not more. Weekend, if you can get 1 2 hours, please arrange that. And trust me, our course is going to be end by 3 or 3.5 months. Maybe 1 week here and there can be there. And after that, you can take maybe 1 more month. and it will not go beyond that. If you are thinking that you were not good to cover, or you lack with the exercises, or you did not get proper time, then you continue with one more batch. You will be getting completely 100% confidence, and then no one can stop you. But this is completely upon you only. I can only guide, I can only support wherever I can, but these exercises are going to help you in the real way. How much you can, this is only the thing you are going to explain in the interview also, and you are going to get in your work as well. Whatever we are discussing, that is completely related to real time work. Same thing you are going to get, and same thing you are going to apply in the real time project work as well. Okay.
Anamika, so is it possible from your experience you can make just a small Word document with the top 20 transformation? So it's, as you said, it's
Of
almost
course I
impossible
can.
to,
Of course I
yeah.
can. You want
So
top
that will be
20?
helpful. Yeah, because
Okay.
for me it is very difficult because with project
No,
work and
see,
all I
one thing,
cannot
one
do my
thing,
hands.
one thing, do one thing. At least run one time, single time, all. Don't write. Even I have given code also, right?
Yeah,
Just
yeah.
copy, paste and run. At least you should have understanding. Let's say you prepare for 20, someone asks the 21st, what you will do? If you know 50% also, 20% also, you can say something, right? You
Yes,
should
yes.
be not
Okay, so I'll
completely null.
just do a yeah. So basically, you're saying just go through everything, everyone each at least one time, then
Right.
remember the
Be
yeah.
confident with the selected one.
Got it, got it.
If you are talking about top 20, then keep in mind that, okay, I am really good with the 21 and I am confident with this. If someone is asking with the what transformations you have used in your project, then in your discussion, you will be focusing more on that only, where you are more confident. So you can explain in a better way. But one time, at least one time, run those as well. So at least 10%, 20% that will be in your mind. At least you can say high level of a single line explanation you can, right?
Yes, yes. Just will do that.
Okay. Okay, fine then. Let's meet tomorrow with the next topic. And if you have any question from today's session, let's discuss tomorrow. Have a good day. Bye.
Thank you.
Bye.